which is about an hour here. So today is the 10th, and I wanted to talk about section 3.1, which is called Systems of Linear Equations in two variables. And just to get started, before we get into the math here, I wanted to just go over some vocabulary, and then I'll show you how all the math plays out. So for the vocabulary, a solution just means an X and Y combination that satisfies all equations. Graphically, where all lines intersect. So that's a solution. We're going to be using the word system today. System just means a group of two or more equations One thing I just want to point out is, in order to solve a system, you must have as many equations as unknown variables. What this means is, if you have 3 equations, you need to have 3 variables. If you have 2 equations, you have to have 2 variables. And if there's 1 equation, generally we have 1 variable. Right? And I wanted to talk about one other thing here. I figured we'd get all the words out of the way from the start. There's 3 types of solutions. There's one type is called consistent and independent. And this just means that there's one solution. So we have 2 lines that cross in one place. We also have consistent and dependent. This just means an infinite number of solutions because they're the same line. And this would just be like if you had x plus y is equal to 2 and 2x plus 2y is equal to 4. All I did is I multiplied the one line by 2, and clearly they're the same thing. And then the third type of solution is something called inconsistent. Inconsistent just means that there's no solution, which just means that the lines are parallel. And we know parallel to mean that they're the same slope. Right? Parallel slope just means that they never cross, or something like that. When you go to solve these, sometimes the answer could look a little strange. Consistent and independent would be a normal answer, like you might get x is 1 and x is 3. Or, I'm sorry, x is 1 and y is 3. That would be a normal answer. A typical answer is called consistent and independent. Consistent and dependent would give you an answer that says 0 is equal to 0. If you ever wound up with that as an answer, that means that it's the same exact line. And inconsistent just means that you get like 0 is equal to 5. Something that doesn't make sense would be called inconsistent. It doesn't make sense because there's no point where they cross. All right. So I hope that's as much vocabulary as we're going to need today. I want to get to the math. So let's take a look at what these problems will actually look like. First set of examples I'm going to ask you are the following. Solutions. 2x plus y equals -6, and x plus 3y is equal to 2. So let's say first example would be -4, 2. Second example would be 3, -12. And remember what we said a solution means. Solution just means that it satisfies both equations, meaning that it makes it make sense. So for this first one, -4, 2, we'll plug in -4 for x, 2 for y. We're going to get 2 times -4 plus 2 is equal to -6. -8 plus 2 is -6. So it works for the first equation. Let's see if it works for the second. X plus 3y is equal to 2. So -4 plus 6 is equal to 2. So I would say that this is a solution because it satisfies both equations. Let's try 3, -12. If we plug 3 in for x, 2 times 3 plus -12 is equal to -6. Let's see. 6 minus 12 is definitely -6. So that looks good. And then if we plug it into the second one, 3 plus 3 times -12 is equal to 2. Well, 3 minus 26 is absolutely not 2. So we'd say that this is no solution. When you get an answer, you could always check to see if it makes sense. All right, let's try something else. Next example. Let's solve by graphing. What if we had a problem like this? 2x plus y is equal to -5, and -x plus 3y is equal to 6. So the way that we solve by graphing is we just get the x and y intercepts. So what I'll do is I'll show you what this looks like. I'm going to go 6 units in each direction. And we talked about how to get the x and y intercepts before the last exam. If you take the equation 2x plus y is equal to -5, to get the x-intercept, what you do is you plug in 0 for y. So you get 2x plus 0 is equal to -5, where x is -2.5, which is right here. To get the y-intercept, we put in 0 for x. So we get 2 times 0 is 0, and then y is equal to -5. 1, 2, 3, 4, 5 right here. Connect the dots. And that's what that line looks like. Let's go ahead and graph that second line. I'm just going to put a blue dot next to this so you know the color, how that coordinates with the lines. For this next one, it's -x plus 3y is equal to 6. To get the x-intercept, we put 0 in for y. The y-intercept, we put 0 in for x. So -x plus 3 times 0 is equal to 6. X would be -6. -6, I'll just put a dot right over here. To get the y-intercept, we put 0 in for x. So -0 plus 3y is equal to 6. Y would be 2. So the question is, where do they cross? This point right here is the solution. Solution looks like it'd be -2, 2. Now, depending on your graph, you might get -1, 3. It's going to be in that general area. The problem with graphing is that you always get an approximate answer. We'll talk more about what to expect on the exam. But on the exam, a question like this, I'd accept if you got -2, 2 or -2, 1. As long as you're in the ballpark, everything would be fine. All right. What about something like this? If we had y is equal to -2x minus 5, and y is equal to 1/3 x plus 6. I put that little bracket on there to mean that it's a system. Those two equations are part of a system. So we could graph this in slope-intercept form. So I'm going to go 10 units in each direction. So for this first equation, this is in slope-intercept form. It's just another way to graph. We talked about slope-intercept form where this is the slope, which we could put over 1 to make it a fraction, and this is the y-intercept. Remember, we talked about slope. If the top number is positive, it goes up, negative, it goes down. So for this particular graph, if we put a point at -5 on the y-axis, and then go down 2 to the right 1, we'd get a line that looks something like that. It's a little faster to graph in slope-intercept form. For that second equation, we could start at 6 on the y-axis, and then go up 1 over 3. And we get a line that looks something like that, and the solution would be whatever this point is. The solution would, it looks like it might be -5, 5. And again, I just drew this very quickly. So if you were a little more meticulous in drawing your graph, it might be different. You might get -5, 4. In my notes, I even have -3, 3. So as long as it's in the same general area, everything's okay. All right. This is called a consistent and independent system. This just means that there's one solution. Same thing with the last problem we did. It's important that you know that vocabulary. To finish out this section, I wanted to talk about how to do it algebraically. So graphing has its limitations. It's fast. Some people find it easy, but you don't get an exact answer. So I wanted to talk about algebraic techniques. And I had a few examples from each. First thing I want to focus on is called substitution. With substitution, the idea is that we get the variable by itself and to replace in the other equation. Let me show you an example. Say we had a problem where x is equal to 10 minus y, and 5x minus 3y is equal to -6. What substitution means is you get the variable by itself. You see how x is by itself? And we replace it in the other equation. So because that x is by itself, we're going to replace this x with 10 minus y. Anytime you do any kind of substitution, we have to use parentheses. So instead of it being 5x minus 3y equals -6, it's going to be 5 times what x was equal to minus 3y is equal to -6. And then from here, it's just algebra to finish it. So if we distribute the 5, we get 50 minus 5y minus 3y is equal to -6, which would be 50 minus 8y is equal to -6. And just finishing, bring the 50 over. -8y would equal -56, so y would be 7. If y is equal to 7, we just plug it back into one of the originals. And we just get x is equal to 10 minus y, but now it's going to be x is equal to 10 minus 7. Remember, anytime you go plugging anything in, we have to use parentheses. And we just get 10 minus 7 is just 3. So the solution would be 3, 7. And it's a consistent and independent solution, just meaning that there's one answer. All right, let's try something else. What about if we have to do a little more work? What if it was 4x plus y is equal to 5 and 2x minus 3y is equal to 13? Well, in order to do substitution, we need to have a variable by itself. So does anyone see a variable we could maybe move stuff around and get by itself here? The first one, the 4x, right? So if we take this first one and just bring the 4x on the other side by subtracting it, y would equal -4x plus 5. Now we're all ready to go. Some of these problems you just have to do a little bit of work to get started. But if y is equal to -4x plus 5, we just plug that into the other equation and everything's the same as before. So this would just be 2x minus 3 times -4x plus 5 is equal to 13. And it's off to the races, right? Just distribute, isolate, and we'll get the answer. I'm going to distribute -3. Combine like terms. Add 15. So 14x would be 28, and x would just be 2. If x is equal to 2, remember what we do is we always plug back into an original. We could use the first one, so 4x plus y is equal to 5. If x is 2, 8 plus y is equal to 5. Subtract the 8. Y would equal -3. So again, we have another consistent and independent solution. 2, -3 would be the answer. That technique is called substitution. I wanted to spend a little bit of time and talk about what's called elimination next. The technique elimination, what we have to do is we multiply one or both equations by a number to get the same number, opposite signs. All right, let's say same number and opposite signs. And then we add. Okay, so let's go through some examples here. An example would be like if you had 2x minus 3y is equal to -6, and x plus 3y is equal to -3. Using elimination, we want to try to get the same number and opposite signs, and then we want to add them. So do you guys see that here? Do we have the same number but opposite signs? The threes, right? So what we want to do is then add. You always add. So if you add these together, 2x plus x is 3x. -6 plus -3 is -9. And then if we just divide both sides by 3, you get x is -3. So sometimes elimination could be a little faster. Sometimes graphing could be faster. Sometimes substitution could be faster. But we have all of these tools at our disposal to use, and we just have to figure out which one's the most appropriate to do. Your midterm is standardized across the school. So I can't really tell you on the midterm if you're going to be expected to do this problem using elimination or do this using substitution. Generally, when I create my own exams, I say, just tell me the answer, and I leave that up to you. When I get the midterm, I'll give you more details about what the school is asking you to do. If x is equal to -3, we could just plug that into one of the originals. So instead of x plus 3y is equal to -3, x would be -3, which we always use parentheses when we plug in. If we add that on both sides and divide by 3, we just get y is equal to 0. So again, we have another consistent and independent solution, -3 and 0. What if we had a problem like this, where it's 4x minus 3y is equal to 8, and 8x minus 6y is equal to 14. Now we don't have the same number and different signs, so we have to make a decision here. Do you want to eliminate the x's and multiply one or both equations by a number to get the same number opposite sign for the x's, or do you want to eliminate for the y's? Well, right, so in class, it was suggested that it's the same equation, just multiplied by 2. Well, all right, I wasn't expecting anyone to get that so quickly. What does that mean if it's the same equation? Either there's an infinite amount of solutions or there's no solutions. So let's see what it is. It doesn't matter which one you eliminate for. I'm going to focus on the x's here. So I'm going to try to get the top to be -8 by multiplying everything by -2. And that gives me -8x plus 6y is equal to -16. The bottom one, we don't have to multiply by anything. And even though I wanted to eliminate the x's, I also eliminated the y's, and we just get 0 is equal to -2, which is one of those weird answers. Does this mean that there's no solution, or does this mean that there's infinitely many solutions? Yeah, this means that's exactly right. So I heard no solution. The technical word for this is inconsistent. What these lines would look like is they would just be parallel. Speaking of weird looking things, how about 2x plus y is equal to 6 and -8x minus 4y is equal to -24? Looks like they're kind of similar. So if we multiply the top to get rid of y by 4, we get 8x plus 4y is equal to 24. And -8x minus 4y is equal to -24. So it looks like they're exactly the same line. If they're the same line, we call that system. Yeah, so consistent just means that there's an answer. Dependent means that it's the same thing. Independent means that there are different lines that cross in one spot. Inconsistent means there's no solution. All right. Do you want one with fractions? Sure. All right. My high school kids, I teach high school, and I tell them that my middle name is fractions. So I teach honors algebra 2. So these are, the highest achieving sophomores in the school. And it's like regular algebra 2, but I intentionally make it much harder for them. That's just the nature of the beast. So the way that I do that is I just make like fractions to bust their chops, and well, but anyway, so it's funny. I'll tell you a little story. We have a little bit of time, but so I tell them, I say, I'll make a test or I'll come up with an example. And I say, do you want easy, medium, or hard? And they're like, we want a hard example. And I say, what's my middle name? And they say fractions. I said, all right, so I'll write it down. And I had one kid that doesn't like fractions. He goes, why couldn't your parents give you a middle name of whole numbers? So they're cute. They're cute. They could be cute once in a while. But anyway, I'll give you one with fractions, and then we'll kind of wrap things up to move on to the next section. So what if I ask you, let's do another example. What if I gave you, let's say 3/2 x minus 3y is equal to 9/2, and 1/3 x minus 2/3 y is equal to 1. If you look at this, it looks like a pretty annoying problem. You have fractions all over the place. In one step, you can get rid of all the fractions. So it goes from being a challenging looking problem to one being just like everything else. We talked about that in this class. Does anyone remember how do you get rid of fractions? What's that? That's exactly what you do. So what we do is if you just multiply by the least common denominator, the first equation, it would be 2. you get rid of all the fractions. In the second equation, the least common denominator would be 3. So I'd recommend you do that. And then once you don't have any fractions, you could figure out how you're going to finish it. So for that first equation, multiplying by 2 would just be 3x minus 6y is equal to 9. That second equation would be x minus 2y is equal to 3. And this looks like a problem we've been working on. So it goes from being, a little annoying looking to being so simple in one step. Would you rather use elimination or substitution here? Elimination, it doesn't matter. If you wanted to, you could do this problem using substitution. You'd get the same answer. If you wanted, you could do this problem by graphing. You could also do this problem using elimination. So we have 3 different techniques to get the same answer. Using elimination, what I would do is I'd multiply this bottom equation by -3 to get 3x minus 6y is equal to 9. -3x plus 6y is equal to -9. And you could see 0 equals 0, which is the same line. It's consistent and dependent, meaning that there's an infinite number of solutions. If you were doing substitution, we want to get one of the variables by themselves. So this would be 3x minus 6y equals 9, x minus 2y equals 3. It'd probably be a good idea to just bring the 2y on the other side, giving us x is equal to 3 plus 2y. So we'll put this in for the x and then finish it. It does seem like quite a bit more work, but it should all work out to the same answer. 3 times 3 plus 2y minus 6y is equal to 9. So 9 plus 6y minus 6y equals 9. Last I checked, 9 was equal to 9, right? So you get the same exact answer. If you get the same thing on both sides of the equal sign, it's called consistent and dependent. There's one little shortcut I want to mention here, and then we'll go to the last section. If the equations are in slope-intercept form, if they have different slopes, that means that the lines cross in one place. So we'd call this consistent and independent. If they have the same slope and the same y-intercept, they're the same line. We'd call this consistent and dependent. And if they have different y-intercepts, they would just be parallel. So we just call this inconsistent. It's just a little shortcut. You don't have to memorize that. But if you had a system like this, y is equal to 1/2 x plus 3, and y is equal to 1/2 x minus 4. Without doing substitution or elimination, they have the same slope, but they're different y-intercepts. So would they be parallel? Same line? Yeah, these would be parallel. All right, so just a little shortcut here. Okay, I wanted to finish with one more section. All right, so the last section is section 3.2.